Welcome back, everyone, to The Explainer. We are jumping right into a totally critical phase in the field maintenance program for jet-class turbines today. We're looking specifically at episode 5.4, covering the LM2500, Aeroderivative gas turbine. We're talking about the incredibly high-stakes world of cold weather chemistry, specifically your antifreeze ratios and water purity. Look, if you're operating a 30-megawatt machine that is essentially a jet engine bolted to a concrete pad, what you spray into it matters just as much as how you run it.
Okay, let's dive right into this. Picture this scenario for a second. The engine has been breathing in dirt, salt, and soot all day, and you need to perform a compressor water wash to get that lost power back, but it's freezing outside. If you wash that compressor with just a plain water solution in freezing conditions, you can literally form solid ice crystals directly on the compressor blades mid-wash. We are talking about thousands of pounds of rotating metal, spinning at over 10,000 RPM. Introducing solid ice into that environment, it's an absolute nightmare.
So, to prevent that absolute nightmare, there is a precise, calculated antifreeze recipe for every single cold weather band this engine might operate in. And you have to hit that recipe perfectly. Getting the ratio wrong, underdosing the mix because you assume it's close enough, is exactly as disastrous as skipping the antifreeze entirely. A weak mix still freezes. You end up with ice on the blades, and you've just created a severe mechanical hazard right in the middle of your maintenance cycle.
Section 1. The invisible threat, water purity. Now, before we even get to those freezing temperatures, we need to pivot and talk about a hidden danger that's there all year round. Because, as it turns out, plain water isn't nearly as harmless to a high-performance machine as it looks.
The compressor blades inside this turbine are made of titanium. It's an incredibly strong material, but it's very chemically specific. If you use low-quality water to wash these blades, you are actively introducing corrosive elements right into the machine. Bad water silently attacks titanium over time, causing hot section corrosion, and it doesn't care if it's the middle of summer or the dead of winter. It's just a slow, invisible killer of your engine's efficiency and lifespan.
What's really fascinating about these exact wash water purity specs is that there is zero gray area. This is a strict engineering checklist that absolutely cannot be bypassed. Let's look at the numbers. Total dissolved matter, it must be less than or equal to 100 parts per million. The pH has to sit perfectly in a band between 6.5 and 8.5. Sodium plus potassium can be no more than 25 parts per million, and your filtration size limit means absolutely no particles larger than 100 micrometers. This is not a suggestion, folks. If your water doesn't meet these exact specs, you simply cannot put it in the engine.
Section 2. The chemical defense, antifreeze ratios. Let's see how all this builds when the weather really turns brutal. We're transitioning to the chemical defense you need when outside air drops from a mild plus 50 degrees Fahrenheit all the way down to a freezing negative 20 degrees. And remember, because of the rapid airflow rushing through the inlet, the air gets even colder once it's actually inside the machine. So, a 50-degree day outside can still drop enough inside the inlet to start forming ice on the blades.
Think of it like this. Imagine using that thin, blue, summer blend windshield washer fluid in your car during a hard January freeze. What happens? You're left with a totally frozen windshield, exactly when you need to see the road. That visceral analogy perfectly explains the catastrophic risk of underdosing your turbine wash mix in winter. If you treat an extreme cold band with a mild weather wash mix, your engine's compressor is going to end up just like that frozen windshield.
And this brilliantly illustrates the massive structural leap required in your chemistry as temperatures drop. We aren't just adding a little splash of antifreeze here. For mild cold, yeah, you use roughly 20% antifreeze. But when you drop into those extreme cold bands, we're talking negative 20 to negative 10 degrees Fahrenheit, that requirement shoots all the way up to 88% or more. The solution becomes almost entirely antifreeze.
The absolutely crucial takeaway here is that this recipe, which relies on specific chemicals like isopropyl alcohol, or, for the slightly warmer cold bands, monopropylene glycol, it scales aggressively. Going from a 20% mix to an 88% mix means your wash solution is fundamentally transforming. This proves why assuming a close enough ratio is such a dangerous game. Guessing your mix when the recipe demands 88% risks physically destroying the machine with solid ice mid-wash.
Let's test this logic with a direct scenario from the field. Imagine you're standing right next to the wash mixing station, and the outside air temperature reading is a very crisp 5 degrees Fahrenheit. What do? Do you use the mild cold weather ratio, or do you need a much richer mix? Think about where 5 degrees actually sits on that sliding scale of thermal danger.
You've got to go with a much richer mix. You definitely cannot use the mild ratio here. Because remember what we talked about earlier, that 5-degree outside air is going to drop even further as it accelerates through the engine inlet. If you try to run the weaker 20% ratio at this temperature, you are practically guaranteeing that ice will form on those titanium blades the second your spray hits them.
Section 3, Conclusion and Next Steps. Just a quick reminder, before this, in episode 5.3, we covered online and crank soak procedures. Now we've fully covered what actually gets sprayed onto those external compressor blades, tracing the whole journey from the invisible chemical threats of plain water down to the severe physical threats of sub-zero temperatures.
Let's rapidly recap the main takeaways of this narrative arc. Number 1. Strict laboratory-grade water purity limits are absolutely non-negotiable if you want to prevent titanium corrosion. Number 2, your antifreeze percentage doesn't just inch up, it scales aggressively from roughly 20% all the way to 88% plus as it gets colder. And number 3, treating your wash chemistry as close enough is the fastest way to cause mid-wash ice and catastrophic mechanical failure.
I want to leave you with one final, provocative thought today. We've just seen how impossibly strict the engineering rules are for the water and chemicals that simply get sprayed on the outside of the compressor blades. If the standard for external wash water is this unforgiving, imagine the microscopic, laboratory-grade particle count codes that the internal bearing oil, the TLO and GLO circulating deep inside the engine, has to meet just to keep this giant alive. We're going to uncover those exacting standards in our next explainer. I'll see you then.